we continue to innovate from previous research projects to research the other robotic hands that can assist post-stroke patients in their primary hand movements. The innovation that we do is in the material and pneumatic mechanism. First, we design a rough sketch of a normal hand starting from the glove dimension and pneumatic finger shape. Because the artificial finger will be made of silicone rubber, pneumatic finger molds are designed first and printed in 3D print. We print for all mold design versions that are prepared for this research. The silicone we use is the type of room temperature vulcanization or RTV silicone rubber. After mixing with the catalyst liquid and blue dye, the silicone is put into a vacuum chamber to reduce the air content trapped inside. The vacuum process affects the strength of silicone when injected with air. After that, the silicone is poured into the mold and leave it for several hours to dry. Before being assembled, electrical parts are tested for their function first, such as pressure sensor, microcontrollers, solenoid valve, and mini-air compressor. This is also useful for testing electrical design from the wiring diagram. We tested all design versions that were finished manufacturing. The selection of the version for the final production based on the production process, the result of the movement, the visual form, and the strength of the rubber. Therefore, the researcher chose the last design version to be produced. For system automation, we use MATLAB Simulink in designing fuzzy logic control and PID control. The system is embedded into the Arduino Mega microcontroller. Each electric component is arranged in a mini-board. Soldering must be very careful and must be in accordance with the design of the wiring diagram so that there is no error in the electrical lines on the board. In the end, we put all parts together into one soft robotic glove unit. Electrical parts and batteries are connected to the glove section to carry out their function. In the final test, we made sure the function of the glove movement mechanism was running well and could hold several experimental objects. We are aware that there are still shortcomings and this glove requires further innovation, but we believe these small steps can mean a lot to research in our country.